is Sir Don, and now we are going to factor out trinomials of the form ax squared plus bx plus c, where the leading coefficient a is equivalent to 1. This lesson, we are going to factor trinomials of the form ax squared plus bx plus c, where a equals to 1. Again, the leading coefficient is equivalent to 1. So we have this first example. Find the complete factors of x squared plus 7x plus 10. So the value of a here is 1. So the leading coefficient here is 1. So we have the solution for finding the factored form of x squared plus 7x plus 10. So this problem is similar with finding two numbers with a product of 10 that if added together will give you a sum of 7. So take note of that. Again, you have to look for two numbers that multiplied together will give you a product of 10. And if you're going to add that together, you will give a sum of 7. So in pattern or in symbol or using a table, we have here the factors of 10. We have both here will give you a product of 10. But if you're going to add, the first factor, which is 10 and 1, will give you a sum of 11. Then the other one will give you a sum of 7. So it means that the second pair of factors satisfies the given condition. So we can now rewrite this one. So this is now the we can consider this one as the factors. Therefore, the factored form of x squared plus 7x plus 10 is x plus 2 and x plus 5, or the quantity of x plus 2 times the quantity of x plus 5. Or you can interchange these two, which is also correct, and that is the quantity of x plus 5 times the quantity of x plus 2. To find the complete factors of x squared minus 2x plus 51. Okay, so this problem is similar with finding two integers that if multiplied together will get 51, and if added together will give you a sum of negative 20. So what are those two numbers that if you're going to multiply will give you 51, but if you're going to add will give you negative 20. Okay, so let's have a systematic solution for that. So all these factors will give you 51. All the factors here will give you 51. That is 51 times 1. But if you're going to add these two, it will give you 51. The second one, negative 51, and multiplied to negative 1 will give you 51 also. However, if you're going to add that one, will give you negative 52. The third one, that is 17 times 3, will give you 51 also, but if you're going to add, will give you 20, positive, which is not the same with the symbol or the sign of the middle term, which is negative. However, if you're going to have negative 17 times negative 3, will give you positive 51. And if you're going to add these two, that is negative 17 plus negative 3, will give you a sum of negative 20. So this last pairing, factor pairs, satisfies the given condition. So therefore, rewriting the factored form, that is x minus 17, or the quantity of x minus 17 plus, times the quantity of x minus 3. Example problem number 3. Find the complete factors of m squared plus 11m minus 26. Okay, so here is the solution in finding the factored form of m squared plus 11m minus 26. Again, the concept is you are going to look for two numbers that if you're going to multiply will give you negative 26, but if you're going to add will give you positive 11. So let's have the test for the factors. So we have negative 13 times 2 will give you negative 26. But if you're going to add that, these two numbers or factors will give you negative 11. So negative 11 is different from the middle term. However, if you have 13 times negative 2, which is negative 26 also, but if you're going to add the two factors, that is 13 plus negative 2, will give you a sum of positive 11. So, our second pair, which is 13 times negative 2, satisfies the given condition. So, the factored form for m squared plus 11m minus 26 is the quantity of x plus 13 times the quantity of x minus 2. Why is it x minus 2? Because you have here the second factor, which is negative 13q minus 13. Okay, so this problem is the same as finding two numbers that multiply together will give you a product which is negative 30, but if you're going to add, will give you a sum of negative 13. So what are those factor pairs? So we have this factor pairs. So we have 6 times negative 5, that is negative 30. But if you're going to add that, that will give you positive 1. And positive 1 is different from the middle term. You have negative 6 times 5, that is also negative 30. But if you're going to add that 1, that is negative 1. And that is also different. So this is a wrong combination. So we have the third pair, 10 times negative 3, which is also negative 30. However, if you're going to add that, that will become positive 7. So we have the fourth one, negative 10 times 3, which is negative 30. However, if you're going to add the two factors, will give you negative 7. Then we have 15 times negative 2, that is negative 30 also. But if you're going to add that, that will become positive 13. However, the requirement should be negative 13. So the last, this one, does not satisfy the given condition. It should be negative. Therefore, if you're going to interchange the signs, we have negative 5 times, negative 15 times 2, that is also negative 30. And if you're going to add these two factors, you will get negative 13. And this is what we are looking for. Therefore, writing the factored form of y squared minus 13y minus 30, that is equivalent to the quantity of y minus 15 times the quantity of y plus 2. Okay, our sample problem number 5. Find the complete factors of y raised to 4 minus 2y squared minus 3. Okay, so we have here the given y raised to 4 minus 2y squared minus 3. Again, you're going to get the factor pairs of negative 3 and the corresponding sum. So this is just the same again with finding two numbers that will give you a product of negative 3. But if you're going to add, will give you a sum of negative 2. So the first factor pair is 3 times negative 1, which is negative 3. But if you're going to add 3 plus negative 1, the sum is positive 2, which is not the same with the middle term. It should be negative. Interchanging the signs, you have negative 3 times 1, which is negative 3. And the sum will be negative 3 plus positive 1 will give you a sum of negative 2. Therefore, the second pair satisfies the given condition. Therefore, the factored form of y raised to 4 minus 2y squared minus 3 is equivalent to the quantity of y squared minus 3 times the quantity of y squared plus 1. To take note that here, we have here this exponent 2 and here the exponent is 2 because the first term has an exponent of 4. Have some problems which is I think different from the given examples, but we can actually apply the concept in this type of problems. Okay, so we have to factor out completely a times the quantity of a plus 1 plus 30. Okay, so we have to get first the simplified form by distributing a to the two terms or binomial inside the parentheses. And that is the same with a squared plus 11a plus 30. So a squared plus 11a plus 30 is actually a trinomial in the form of x squared plus bx plus c, wherein the leading coefficient a is 1. So we have to think for a factor pair that the product is 30 and the sum is 11. So here are the factor pairs. So 3 times 10, that is 30. But if you're going to add the two factors, will give you a sum of 13. We have negative 3 times negative 10, which is also 30. But if you're going to add, that is negative 13. So negative 30 is different from the middle term. 2 times 15 is also 30, but if you're going to add, he'll give you a sum of 17, which is this different from the middle term. Negative 2 times negative 15 is also 30, but added together will give you a sum of negative 17. Negative 6 times negative 5 is also 30, but if you're going to add this, 2 will give you a sum of negative 11, which is different also because the middle sign or the middle term has a sign of positive. However, if you have 6 times 5, which is 30, will give you a sum of 11. So therefore, this pair satisfies the given condition. So, the factored form for a times the quantity of a plus 11 plus 30 is a plus 6 times the quantity of a plus 5. So that's it for today. So just a few reminder. To factor a trinomial of the form ax squared plus bx plus c, wherein the leading coefficient a is equivalent to 1, you have to find two numbers with a product equal to c, or the last term, and a sum equal to b, or the middle term. The factored trinomial will have the form the quantity of x plus the first number, which is the first factor, times the quantity of x plus the second number, or the second factor. So thank you very much for listening. I hope that you learned something for today.